Welcome. My name is Chuck Ridgway. I'm the Automation Technology Manager here at Horner, and we've got another Tuesday live stream for you. Today's topic, wiring Horner Micro OCS all-in-one controllers. This is a little bit of a different topic than we've done. We're not covering a protocol or a product feature or any of those sorts of things. Today it's really all about things or factors that impact installation. So joining me again today is Mr. Casey Gardner. How are we doing today, Casey?
Hey, not too bad. How's it going, Chuck?
It's going well, and I'm anxious to, or not anxious, but I'm excited really to kind of present a little different type of information this week. So I know you had a chance to take a look at the materials ahead of time. What do you think of today's subject?
Yeah, I think it's an interesting one for sure. It's wiring practices aren't always kind of discussed. More of it's if it works and fits the right connector, kind of use whatever. But I think there's a lot of good tidbits of information that we got in there, whether it's sizing of wiring or different connectors or different types of terminals you use, or kind of a number of different things to kind of ease the process and make it all fit the appropriate installation better, so to speak. Because there's definitely not a one size fits all in the control world, especially when you go anywhere from your whether it's a microcontroller versus regular or really built for the application.
Sure, and one of the reasons I think today's program will be really useful is that the Micro OCS series is one of our newest product lines. It's very cost effective, but it does use some slightly different connectors than we've used in the past. And I know we've had some questions from customers, what wire gauge should I be using? Can I use ferrules or not? What do I do about CAN wiring? Those sorts of questions, as much for a lack of familiarity as anything else. So those are the questions we're going to hope to answer today. So let's go ahead and get started. And before we do that, I want to mention that Casey will be manning the chat today. If you have any questions, feel free to chat those up at any time. Casey will either answer them directly or he'll bring them to my attention for at the end of the session. All right, let's go ahead and get started.
Sounds good.
Okay, today's topic again, wiring Horner Micro OCS all-in-one controllers. So really what we're going to talk about today are all the different connections that you can make to the Micro OCS. And from an installation standpoint, what are some of the hints, the tips, the tricks that we can give you to make that process as smooth as possible? Because the Micro OCS is a relatively new product line. A lot of you are very familiar with our products from the XL series to even earlier products. Some of you are new to Horner in general, and we feel like this will be great information to help things go really smoothly with that new installation. One thing that you probably realize, if you know anything at all about the Horner OCS controllers, is they have lots of connections. And that's definitely true with the Micro OCS as well, even though it is our budget product line. Now, specifically for the Micro OCS, we selected connectors which in some cases are different than those we've used before. And the reason for that is we not only designed for functionality, but size and cost. The shape of the Micro OCS is different than the products we've used in the past. It's much shallower in depth. The cost is crazy and expensive from the standpoint of the functionality that you receive. So that caused us to use some different type of connectors than we may have used in the past. Now, one thing that's really nice about the Micro series is that whether or not you select the X2, the X4, the X7, the X10, those products use exactly the same connectors regardless of the product size. So whether it's a $200 2-inch screen up to the 10-inch widescreen that we just released in the X10, all those connections are exactly the same. Now, aside from those four models, we've also got our model X5, which does things a little bit differently. So we're going to cover that one as well. Okay, so we're just going to kind of work our way through the different connections on the product, talk about the different installation factors, and just motor right on through. So of course we're going to start with power and ground. All right, well, what could be difficult about that? Well, nothing very difficult really. Now, one thing that is consistent with the Micro OCS is we're using the same 3-pin connector that we've used for many, many years for power for all of our products, including the XL series. And there's really 3 signals that are coming in, or connections that are made through that connector, and it's, again, been the same for years. That's DC power, as of course the positive signal, DC common, as well as earth ground. All right. Now there are some variances in terms of the voltage range among the Micro series, so that's something to be aware of. With the X2, the X4, and the X7, those products require 24 volts plus or minus 20%. So it's a pretty generous spec there, but it's definitely centered around 24 volt operation. With the X10 and the X5, those products can also be powered from 12 volts as well, even though their lower end of their range is a little bit different. Now, one thing I wanted to point out with the Micro OCS, and that is that the minus signal, or the voltage common, that's coming from the main power supply, the 24 volt power supply, it really has many connections on the Micro OCS product itself. So that common signal has the same potential as all the I/O commons, whether it's digital or analog I/O. It has the same potential as the CAN common, the same potential as the serial port common, and the same potential as the USB common. So all of those signals have the same potential. Now from an earth ground standpoint, however, the earth ground connection coming in that's the only place it goes. It has a connection on the circuit board, but none of the other connections that are made by users are directly equivalent to the earth ground signal. So just a single earth ground connection on the product. Now, anytime you're installing the product, you should obviously go for the best ground that you can. You're gonna try to get as close to 0 ohms as possible, but technically anything up to 15 ohms is considered an acceptable earth ground. Now, in terms of the connector that we use on the standard power connector, it's a 3-pin plug with 0.2 inch spacing, which is equivalent to 5.08 millimeters. It has a flat screwdriver in terms of it's a screw type connector, and you use an M3 screwdriver, or the English equivalent, to operate it. It's rated for 300 volts up to 10 amps, and you want to strip your wires back to 7 millimeters. Okay, so that's the key factors there. Now, taking a look at the wire sizes, again, this is good information, I believe. If you're talking stranded wiring, you're looking at anywhere from 12 to 28. Of course, you're probably not going to want to use anything nearly that small. I'll talk about specific recommendations in a little while. But you can technically use anywhere from 12 to 28. And you can choose to use ferrules. If you do, your wire size has to go down just a little bit. You can use up to 12 gauge wire with stranded with no ferrules. You're limited to 14 gauge if you decide to use a ferrule. Okay, if you use a double ferrule, 2 wires of equal size going into a ferrule, now you're limited to 16 gauge as the largest wire. Okay, so before we move on past the power connector, I'm going to go ahead and just quickly show you, what things look like here and what type of wires and what sizes of wires we can use. So let me go ahead and turn on my overhead camera here. Okay, so let's start with the largest cable that we can use here. Now we're talking about this 3-pin removable power connector. All right, what I have here is a 12 gauge stranded wire, and it goes in. Now it is pretty much the largest size that you can use with this particular connector. If you wanted to use a ferrule with this particular size, 12 gauge, that's definitely a no-go for sure. Okay, so no luck in getting that guy in there. However, if you are looking to use a ferrule, you can just bump up to 14 gauge. So obviously 14 gauge stranded goes in without any difficulty at all. And even with the ferrule, you can use that as well. Okay, so with the ferrule, it does go in. Hits the sides a little bit, but it does comfortably go in and go out. And anytime you're trying to verify that a certain wire size will work with a ferrule, it's important that the wire goes in easily both in and out. Because sometimes what you'll have, if the wire size or the ferrule size is right at the edge of what's acceptable, sometimes it'll go in, but when it comes out, it can damage the connector. But in this case, if you're talking about using a ferrule with this particular connector, a 14 gauge ferrule is not a problem whatsoever. And it really doesn't make a ton of difference whether the die on your ferrule crimper is a flat bladed type crimper or a square one. Although the flat bladed ones in general do work better, allowing you to use larger wires in smaller connectors. So that's something to keep in mind and something we'll talk about as we go along in the program. Okay, back to the material here. Okay, so that's the power connector. Pretty straightforward. Again, this is not different than what we've used with the XL Series OCS in the past. From a recommendation standpoint, now that we've taken a look at what is possible, our recommendations are as follows. So we would certainly recommend that you use either a 14 gauge or a 16 gauge wire for power. And when it comes to earth ground, we would recommend a 14 gauge wire for that. All right. One of the big benefits of using the 14 or 16 gauge wire for power is it not only provides ample copper to provide the right amount of current, although the Micro OCS products don't draw a lot of current, but it provides an appropriate amount of copper for the return signals. And if you remember from just a couple of minutes ago, I mentioned the fact that return, that voltage common, is shared among all kinds of signals on the Micro OCS I/O. So all the I/O returns, communications returns, those sorts of things, all are with equal potential to the voltage common. Okay, and then on the earth ground standpoint, having a 14 gauge wire connected to a good earth ground is just a good practice and will help you get to that target of being as close to 0 ohms as possible, with again the thought that you could sneak into maybe up to 15 ohms if that's as good as you can do. Okay, so that's the power recommendations for the Micro OCS. All right, now we're going to move on to the I/O connections. Now the I/O connections, frankly, are one of the topics that has come up a lot with customers because they're really having to get used to these smaller connectors than what we've used before on most of our OCS products and certainly on most of our I/O products. First of all, from a usability standpoint, the plugs are color-coded. You've got 2 orange plugs for the digital inputs as well as the analog signals. You've got a black connector that is used for digital output signals, whether they're relays on the Model R for the Micro OCS or whether they are strictly solid state on the Model A. All plugs are removable, so there's no fixed terminals or anything like that. You should typically use a small flat-bladed screwdriver to remove them. Okay, it's been designed so that you can go ahead and pry up on one end to get the connectors removed. And then this is something that's definitely caught some folks. You definitely have to press solidly on these connectors to make sure they seat. We have had some customers that have complained that they've had plugs pop out, but generally it's because they weren't completely seated when the plugs were installed. And it's not the easiest thing to do. We'll be the first to admit that, and we're always looking to make improvements where we can, but you definitely need to make sure that the plugs are fully seated by pressing solidly on both ends of the connector. So that's an important factor for sure. Now, these are 3.5 millimeter plugs, and they use a slightly smaller screwdriver, an M2 screw type. They're rated for 300 volts, 8 amps, so you can actually get a fair amount of current through these conductors for sure. The strip length is a little bit smaller than the 508 plug for power. It's anywhere between 6 and 7. 7 still works fine, but you can go a little bit less than that as well. And then we've got a chart here that kind of shows you some of the possible wire sizes when it comes to the AWG of bare copper with stranded wire as well as the ferrules. Okay, let's go ahead and head back to the overhead camera and let's start taking a look at some of the wire sizes for these guys. Okay, so let's start off with 14 gauge wire. So if you're talking about with no ferrules, all right, and you wanted to plug in a 14 gauge wire, that's pretty much the extent of what you're going to be able to plug in there. Now, one thing to keep in mind is just because you can use 14 gauge wire doesn't mean you necessarily need to or should want to, frankly, because 14 gauge wire has a fair amount of ampacity to it, carries a fair amount of current. It also has a fair amount of rigidity and a lion's share of the signals that are connected between the Micro OCS and typically your field terminal strip inside your enclosure, they don't have anywhere near the requirement for the amount of current that can be carried by a 14 gauge wire. And a lot of us, frankly, these days may still be using larger wire like this, mainly just because we've always done it that way. So now if I flip this wire around with a ferrule on it and I attempt to connect it with a ferrule, you'll see that, yep, it's a no-go for sure. No luck on the ferrule. I could try and force it in there, but that would be silly. So 14 gauge is possible if stripped, but it isn't necessarily the best choice. All right, now let's bump up to a 16 gauge wire. Okay, 16 gauge wire goes in fairly easily, actually quite easily, if you're talking about with no ferrule on it. And then now when I plug it around with a ferrule on the 16 gauge, that's almost going in, but not quite. And once again, I could force it, but that would be a mistake. Now, one thing you'll notice about this, or it's difficult for you to notice about this, is that particular ferrule that I just attempted to put in there uses a square crimping tool. Now, there are different dies that you can get, different crimping tools that you can get for ferrules. There are ones that give you more of a rectangular crimp or a flat crimp, and there are ones that give you more of a square crimp. With the Micro OCS, there's no question that the flat crimp or the flat crimp is definitely superior. And I'll show you, this is a 16 gauge ferrule with a flat crimp, and it's sliding in and out extremely easily. Okay, so again, the crimper die or the crimper shape can make an impact on how well the ferrule goes in and out of the connector. So if you wanted to, you could certainly use 16 gauge with ferrules, especially or only if you use a flat crimp. Now, when we go up to 18 gauge, all right, then it's really no problem either way, okay? Regardless of the die that I'm using here, whether it's flat or whether it is square, I'm able to use an 18 gauge connection without any difficulty at all. And I'll go ahead and switch to a square one here, and you'll see that, yeah, once again, with an 18 gauge wire, it's not a problem either way. Okay, so hopefully that'll give you an idea about the gauge of wire that you can use. And keep in mind, 18 gauge, 16 gauge, those are perfectly reasonable type wire gauges to use with a product these days. And they certainly work really well, and frankly, could give you a little less of a headache than some of those larger wires like the 14 gauge, for instance. Let's head back to our presentation, continue on now. So here's some recommendations that I've got for using the I/O connectors. And just like I demonstrated through the different wire gauges and the different ferrule sizes and even the different die shapes on the crimper, use smaller wire gauges if you can. And there's multiple reasons for that. Again, a lot of times we use larger wire gauges mainly because we've always done it that way, not because we really need them. When you seat the connectors, the plugs, make sure you seat them well, okay? So you need to press down solidly, preferably until you hear a click, although you don't always get a click. And then after you've done your wiring, do an appropriate job of strain relief so there's no strain on the connectors. I mean, that's kind of a natural thing, but I think some of us get a little bit spoiled with some of very large connectors we've used over the years, that they don't necessarily need a strain relief, whereas with the smaller connectors, it's usually a little more important to properly strain relief the wiring, and it's just going to end up with a better result on down the line for sure. Also, another thing that I see customers doing from time to time, and they just don't necessarily know better, and that is, keep in mind, you don't need to make every common connection. So depending on which model you're using, you're going to see anywhere between, say, 5 and 8 different connections on the 3 I/O connectors that are labeled common. And people are immediately thinking, okay, I've got to connect every single one of those commons down to my field terminal strip. In reality, that's not the case. Okay, I've already covered the fact that through the power connector and the voltage common that's connected on the power connector, you do have a return path. And so at this stage, you should really just use the common connectors on the back of the Micro OCS that are convenient to use. you don't have to use them out of necessity. Okay, again, if you have a good voltage connection on the power supply going into the unit, which you have to have for the unit to run, then you've automatically got a return path. Now, for things like analog signals and maybe one input connection for common, maybe one output connection for common, it might be convenient to wire a few extra conductors to the common terminals, but keep in mind that strictly for convenience, it's not required. Now, one thing I do want to mention, and that is on the relay version of the Micro OCS series, those commons for the relays themselves are labeled C1, C2, C3, etc. And those, of course, are both mechanically and electrically isolated from the voltage common, which we've been talking about here. Again, so you don't need to connect 7 or 8 or even 5 conductors for voltage common from your field terminal strip up to the back of the Micro OCS. That's definitely not required. Now, when we're talking about analog, really a goal there is 2 things. In addition to picking the right gauge, and again, with analog, now we're really talking about much smaller wire, frankly, is what we traditionally use for analog. But when we're talking about cabling, we almost certainly always want to use shielded twisted pair wiring, okay? And we want to make sure that we ground or earth ground the shield drain to a good ground that's away from the Micro OCS. So the goal is to get any noise that's picked up by the analog wiring away from the instrumentation, away from the controller, by grounding at typically the other end of the cable. Or even if you're grounding it on the control panel side, you want to land that ground down in a good panel earth ground and away from where you're landing the plus and the minus signals into the analog terminal block on the back of a Micro OCS. So those are just kind of some simple things to keep in mind. But definitely make sure you earth ground that shield. Don't just leave it hanging there, because then it's like an antenna. That's not what you want for sure. And now getting to the more specific recommendations that I would like to make for those of you who are looking to use the Micro OCS on a project. Like I mentioned, if you want to use ferrules, I know I love to use ferrules, use a flat crimper, okay? And let me show you the difference between those two real quick here. Again, I'm going to go quickly give you the overhead view. Hopefully you'll be able to see this. So here's an example of what you would typically find for a crimper that's going to give you a square crimp, okay? It's going to, as you can see, as you ratchet it, it's basically just the square gets smaller and smaller, but it's definitely a square crimp, okay? So these are effective, but when it comes to smaller type connectors or wires that are close to the size, the maximum size allowed for a plug, these are definitely not preferred for sure. The better choice would be, and again, this may be difficult to see. Let me see if I can get it up here close enough. Yeah, it's going to be a little bit of a challenge. But what we have here are, this style of crimper is going to give you more of a flat crimp. And if I ratchet it down a little bit there, I think you can kind of tell that those are more rectangular in their shape than they are square. Sorry for the bit of out of focus there. But that's what I'm talking about when I'm talking about a rectangular crimp versus a square crimp. That's really what I'm talking about there. So again, if you're going to use ferrules, I would highly recommend that you use a flat crimper. It just gives you more options in terms of wire sizes. In terms of the wire gauge, I would say don't be shy at all about using, smaller wire on your digital inputs, especially. 18 or 20 gauge, not a problem at all. On the analog side of things, we've been using smaller wire for years. The typical analog wire you're going to find is going to be 22 to 26 AWG, and remember we're recommending shielded twisted pair as always the best choice there. For digital outputs, it really just comes down to current draw. Now if you're talking about signals that are well less than 1 amp, again 18 to 20 gauge, not a problem, certainly can use that. If you're talking about signals that are greater than 1 amp, then you're going to want to probably use 16 gauge wire for that. Okay, so those are my recommendations from a wire gauge standpoint with the Micro OCS. Okay, next let's talk about the X5. And the reason I'm kind of jumping in now with the X5 is because what's really different about the X5 in terms of its connections are the actual I/O connections themselves. That's actually the big difference here with the X5. So next I'm going to go ahead and bring an X5 in. But before I do that, I do want to mention that the main differences in the connectors are the fact that the X5 uses it's still a 3.5 millimeter pitch, but it is a spring clamp style connector, and it is a deeper connector. So the amount of insulation that you need to strip away from the end of your wires is 10 millimeters, not 7. It's 10 millimeters, and therefore if you're going to use ferrules, you need to use ferrules that have a barrel length of 10 millimeters, not 7. While you might be able to get away with it, you're going to be much better off by going with a 10 millimeter barrel length on your ferrules. And also, of course, you're going to want to strip away that length as well. Okay? And for the X5, using a flat crimper is absolutely critical because it just does not work well with a square crimp at all. And then in terms of the recommendations that we're going to make there, certainly for digital I/O, I would recommend anywhere from 18 to 22. For analog I/O, the standard 22 to 26 will be just fine. Okay, let's take a quick look at the connectors now on the X5. All right, there we go. I've got my X5 here. Now, if we're talking strictly about, let's say, no ferrules at all, and the first thing some people might say is, well, let's go with a 16. All right, I'm not going to try a 14, but let's go with a 16. Really, 16 is not going to fit well, even if you aren't using ferrules. Pardon my reach here. As I push down on that, it's just not going in smoothly. So I definitely would not recommend 16 even on the X5 product. So let's go ahead and bump up to an 18. All right, and what I have here is an 18, and I can plug it in here. And actually, one of the nice features of the Micro OCS X5 is these are push-in style connectors. Now, at first glance, it's like, oh great, I'm golden. I've got an 18 gauge long ferrule here. That's going to work perfectly. Well, the problem is it goes in fine, but it doesn't come out fine. And that's not what you want. All right, I was able to get it out, but it was a bit of a, it was a bit of a struggle. So 18, I would say, is marginal. I think you certainly, if you use a flat crimp and you use a long ferrule like you should anyway, you can use it, but it's a little bit marginal. Okay, I would say that's the upper limit of what you can use. Now, if your application were to allow you to use 20 gauge wire, and I wouldn't see why not in almost every case, now I can go ahead and push this in, and then when I use the actuator here, I can easily bring it out. So again, I know I'm probably my hands are getting in the way here, but it goes in smoothly, and then it comes out very smoothly as well. So again, a 20 gauge ferrule with the 10 millimeter barrel on it is certainly what I would recommend for the X5 if you're talking about wanting to use ferrules at all. And again, I think a lot of us do like to use ferrules. Okay, so that's the recommendation on the X5 side of things. All right, and once again, anywhere from 18 to 22, 20 works really well, as you've seen with ferrules. And then again, on the analog side, you're going to typically use smaller wire anyway. All right, now we've talked about power and we've talked about I/O, and that's frankly a lot of what we need to talk about. But now let's also not neglect the fact that some of the other connections on the Micro OCS are different than maybe what we're used to, and that certainly includes CAN. So with CAN, we've started using in recent years, and it's definitely true on the Micro OCS, we've started using modular connectors, RJ45 connectors, and this is actually a trend in the industry. We're not the only ones doing this. And whether you're using the CAN connector for I/O expansion or for communications from OCS to OCS, again, this CAN connector is pretty practical. It just takes a little getting used to. Just like any other CAN network, your network will need to be terminated. However, with the Micro OCS, we do make it easy on you because you can do the termination from the system menu if you choose, if the OCS happens to be at the end of the line. Or you can choose to terminate the old-fashioned way, maybe on the field terminal strip as opposed to directly on the back of the OCS. Now, a lot of people will say, well, how do I get the CAN cable connected into these RJ45 modular jacks? How can I do that? Well, patch cables can work very well. European drive manufacturers have been using RJ45 and Cat5 cabling for can open for servo drive applications for years, and they've had very good success. So patch cables absolutely can work well, especially if you're just talking about a cable that's inside the control panel or in generally low noise environments, for sure. And again, I may not have mentioned this, but unshielded cabling for the modular jack connections or the patch cables is all you really need. You really don't need the shielded cabling for that short stretch of cable. If you've got a long CAN network, and obviously you're going to want to connect traditional CAN wiring to that Micro OCS, for instance, then yes, you're going to be using, outside of the enclosure, you're going to be using traditional CAN type wiring, and you're going to be doing all the right things with your shield drains and those sorts of things. But for that little stretch from the terminal strip inside the enclosure to the back of the Micro OCS, shielding is absolutely not required in almost every case. Okay. Now, if all you're going to do is add, let's say, an I/O block or two inside the panel, and that I/O block has a traditional 5-pin connector on it, then you can either build or buy from us a RJ45 to 5-pin cable assembly. And basically, we just construct it using category style cable, and we connect to the appropriate conductors. The CAN high and CAN low signal, in the case of category type wiring, that's the orange and orange-white pair. And then the common signal in category style wiring, that's the green-white signal. That's pin number 3 on the category side of things. So that's what your options are there for using a modular jack with CAN. It's really nothing to be concerned about. It's just a little different than what we're used to, I'm sure. Now, we've been using modular jacks on serial ports for some time, but I thought it would be a good idea to cover this as well. And what we do on the Micro series, that we've done on some of our other products for a while now, is we basically give you 2 serial ports on a single connector. So you still have both an RS-232 port and an RS-485 half duplex port, both available to be used simultaneously, but they're both on the same physical connector. And you can see the pin out there on the screen. Now, to make wiring easier, we do have an accessory that is extremely popular, and that is a RJ45 to terminal strip style adapter. And if I can find one here, I've got one to show you. All right, let me go ahead and switch back to the overhead camera. Okay, so this is the adapter. You can see on one end it's got a modular jack or modular plug. On the other side you've got 8 terminals. Now notice that, and let's see if I can get this up here a little closer. It's not going to, oh, there we go. Notice that the pins are not 1 through 8 left to right. They are basically, you do have to pay attention to the silk screen or the sticker on the adapter to make sure that you get the right conductor connected to the right terminal strip. But these are very handy products if you're using it with, let's say, a serial port. Now it's a lot easier, as you can see, to wire that serial port using traditional communications wiring into that modular jack. If we're going to talk about, let's say, a Micro series product, maybe an X7, I'll bring in an X7 here. You can see the way that that guy is aligned. It's also, again, very easy to make those traditional serial type cabling connections on the modular port. Now, some of you might say, well, geez, what about termination resistors on RS-485? That looks like that could be tricky with those small terminals. The good news is you can just use the system menu in the OCS to enable and disable termination, and you can do the same thing with biasing as well on the RS-485 signals. Now, back to shielding. This is really important. If you're using shielded comms cable, which is always a good idea, you need to connect the drain to an earth ground. Don't just leave it floating. It'll attract noise that way. And just like with analog signals, you need to connect that drain to a good earth ground, and you should do it away from the OCS side of the communications if you can. For instance, let's say you've got a variable frequency drive and an OCS that are talking to each other over Modbus RS-485. That's the most common application in the world. In that scenario, a lot of the noise is being generated, of course, on the variable frequency drive side of the communications. That's because those are very noisy components. So on the shield on the VFD end, that would probably be the best location to go ahead and do the earth ground, as opposed to doing it on the Micro OCS side. So that's, again, a very important factor that you don't want to lose sight of. Okay, now we're kind of getting towards the end of our connections here, where things get a lot simpler. Ethernet and USB. So with Ethernet, unshielded patch cables are fine. 95% of the time, getting shielded cables is not critical at all. If you do decide to use shielded cables, you need to make sure that the shield gets earth grounded. Okay, and again, it should be at the opposite end from the OCS. That's definitely something you want to pay attention to. And then on the USB side of things, it's just a matter of buying the right cable. It's included in the Horner OCS cable kit, and that is a mini B type connector, not a micro B, which is probably between micro B and USB-C. Those are probably these days becoming the most common connectors available. You want mini B, which is a little bit larger, a little bit easier to use in an industrial type environment. Okay, so that's Ethernet and USB. So before we preview next week's session, I think that pretty much wraps up what I wanted to cover for today's session. Let me go ahead and bring Casey back in. Okay, Casey, so, a lot of kind of different information than we've shared before. Wire gauge, what ferrule should we use, shoot, what shape should the crimper be, all those sorts of things. But those are all little details that can make the installation a lot easier, I think.
Absolutely. We didn't have any questions come in, so you must have covered it pretty well. But even myself, I would absolutely double down on that 8-pin RJ45 breakout connector that we have, because as an applications engineer for testing in numerous different types of signals, whether it's RS-232, 485, 485 full duplex, or CAN, those things come in extreme handy by just chopping off the end of an Ethernet cable and wiring it out however you need to be. So I would absolutely encourage everyone for that. It's a HE200 MJ2 TRM, I believe, because I've used it so much.
Absolutely.
I remember the part number.
We do sell a bunch of those, and it's understandable because, like you said, they're really functional. One other little tip I wanted to mention that I forgot to mention during the program, and it's kind of a rare thing, but one thing to be aware of is, for convenience purposes, there is 5 volts available on the MJ1/2 port. So if you have like a GPS receiver that needs 5 volts or some other device that just needs a little bit of 5 volt power, you can power it from the MJ1/2 port, which is really nice. However, you have to be careful that as you're running signals away from that port, that you don't accidentally, run that 5 volt signal out over a 2,000 foot network, for instance, through a little bit of carelessness in your pinout. So that's something to look out for, is one of the pins on that MJ1/2 port is 5 volts DC.
It looks like we got one question coming in from John. Is there any issue using a push-to-connect terminal strip like the one from the X5 if you buy it yourself? It looks like he's found some from Phoenix that fit
yeah, no problem. So that's one of the benefits of the plugs that we have used on all of our products. We don't have any proprietary connections that we include on our products. So with the traditional XL series, they're primarily 5 millimeter connectors for I/O. Okay, most of our products are available with screw type from the factory, but some are available with spring type from the factory. But if you have a special type of plug that is the right spacing, the 5 millimeter spacing, and for whatever reason that would work better in your application, feel free to use it, no problem. Same thing with the Micro OCS series. Yeah, it uses 3.5 millimeter size plugs, but it's a standard size, and as long as there's no mechanical interference, you can certainly use a third-party plug that may have some characteristic that you prefer to the ones that we include from the factory, and there's no issue with that.
It looks like we got one more. This is more of a suggestion maybe for a future topic to kind of piggyback on this one. Kevin's saying a different kind of wiring tip and trick. He'd like to see more examples of how to route wires from the controller to the door, on the door, into the actual cabinet for their
Okay.
terminal strip. So, might be
Well, sure,
something
but
to
hold
look
on one
into in the
second.
future.
Let me go ahead and grab something real quick. Well, I guess I don't have one really handy. What I like to use for that, and I'll just answer that verbally because I think people can visualize what I'm talking about. What I like to use for that, if I can, is I like to use multi-conductor cable. So let's say that you've got an application with, let's say a dozen I/O or something like that, or maybe even less than that, whatever the case may be. And it's mostly inputs with a couple outputs. We're not talking necessarily a lot of analog or anything. Let's say a multi-conductor cable that is, let's say, 8 or 10 20 gauge or maybe 22 gauge even conductors inside of an overall jacket. That can be a really good choice for routing the cables from the back of the unit along the hinge to the back plate. Because remember, if you take a look at the ampacity capacity of the conductors, generally what we're using them for with inputs and even digital outputs, where at most we're driving half an amp in a lot of these cases. A lot of times it's far less than that. We don't need huge wire gauge. So going with a 20 gauge multi-conductor cable assembly is a great approach, and you automatically end up with a nice neat bundle that you can easily route, just like a communications cable, really, just a little bit thicker than that, right along your hinge to make it easy to get those signals between the back of the OCS and wherever they need to go. Usually it's a field terminal strip inside the same enclosure. So that's one trick that I use, that I like to use because it's just so convenient.
Awesome. I think that covers the rest of what we got in today.
Fantastic. Okay, so next week, let's not forget that next week we have, in this case, a programming related topic for our Tuesday live stream. We're going to talk about using structures with variable-based advanced ladder. Sometimes we call it tag-based ladder. Really what we officially call it is variable-based advanced ladder. One of the advantages of a variable-based language, including a variable-based advanced ladder, is the ability to use structures. So we're going to talk about how you can use those, what they can be used for, the utility of using structures, all those sorts of good things. And then don't forget that even though that's our topic for next Tuesday, pretty much every Tuesday we've got a different topic for you, 2 o'clock Eastern, again, every Tuesday, and we really appreciate it when you watch live and you can ask questions. But also, you have an opportunity to watch those sessions from our YouTube channel and just see them on replay when the information is more relevant. Oh, looks like we've got a couple. I've got Marcy interrupting me real quick here. We have a couple more questions. Let's go ahead and bring Casey back in. And hold on one second. There he is. Okay, so that was a false ending. Never mind.
You just popped in on us. So the first question we've got is, do the XL series metal mounting clips work for the mounting for the Micro
They do,
series?
yes. They absolutely do. And they're available as a separate accessory if you want to purchase them from our web store or from your local distributor. Yeah, they absolutely do. The clamps that are included with the Micro series are a little different design, but the original design that's used in the XL series with an all metal construction, those are compatible with the Micro series as well.
Perfect. And then we have one more that is asking, can we have a XL7 measure the charging amp and voltage? I think it's kind of a separate.
Okay, so can an XL7, what was that? Run that by me one more time.
Yeah, I believe the way it's worded is, can we have an XL7 measure the charging amp and voltage just in general? It looks like he's seeing the reference for your internal battery. He's just looking for a...
Okay, so understood.
External.
If you're looking to... Okay, so if you're looking to use instrumentation to measure battery voltage, that's not really available if you're talking about the battery built into the OCS. Now, we have had customers, let's say in solar applications or applications with, large battery backup for alternative, power sources, those sorts of things. But certainly we've had customers in solar applications, as an example, use analog inputs to monitor battery voltage for external batteries for a system. And typically in those cases, in some cases we've done some customization on the circuitry side of things. In other cases they just used a voltage divider because the voltage exceeded 10 volts in the external batteries, and to bring that signal in and measure it accurately, you need a voltage divider to get that voltage down. So that certainly has been done. Now, if you're specifically interested in the battery voltage inside of an OCS, that's available in a system register. So there is a specific system register, I believe, that will give you the battery voltage. Is that right, Casey, or am I thinking of that wrong?
Yeah, there's definitely a system register.
Okay, right. So I think you not only have system register bits that will tell you if you've got a low battery or a battery fault. I believe there's also a system register you can monitor that will give you the voltage level for the battery as well. Keeping in mind that I believe while that battery is charging, it does not necessarily have the capacity of reading that voltage accurately. So I think what you would really need to do is monitor the battery voltage system register and monitor the system bit that tells you the state of the battery. Is it charging? Is it waiting? Etc. And then make sure that you're only monitoring the battery voltage, or at least paying attention to the battery voltage, when it's not in the charging state. So that's my understanding of how that would work. Okay, so we think we've got it for the questions now?
I think
all right,
so.
very good.
That's
We love it when we get questions. Don't worry. I don't mind extending an extra couple minutes at all. All right, so once again, just to kind of remind you, every Tuesday at 2 o'clock, we've got a new topic for you. Next Tuesday happens to be using structures with variable-based programming. And once again, I want to thank you for joining us today for our Tuesday live stream. We look forward to seeing you next week. Stay safe, everybody.